Good morning, children. Today we are going to discuss very important, friendly and your favorite topic, differentiation or derivative. It is friendly because it helps you out to score 8 marks in your board examination. This chapter has a weightage of 8 marks bifurcated in 1 marker, 2 marker and 4 marker questions. Children, you have come across this word differentiation or derivative in class 11th also. You have calculated the differentiation or derivative of a given function by first principle method, and the first principle method was f dash x equal to limit h tends to 0 fx plus h minus fx whole upon h. So this is your first principle method which you have applied to find out the differentiation or derivative of a given function. Children, you have also come across some of the rules of addition, subtraction, multiplication or product and quotient rule. Now let's discuss or recall one by one these rules. So first of all, if your function is given in addition form, then you have calculated its differentiation as differentiating the first function plus differentiating the second function. That means if your function is given in u plus v form, then you can differentiate the first function plus differentiation of the second function. If it is given in minus, then you have written as differentiation of first function minus differentiation of second function. Second, if your function is given in product form or in multiplication form, this is also known as Leibniz rule, and you have applied it like this. First term as it is differentiation of second plus second term as it is differentiation of first term. That means you have kept over first term, any one of the term as it is, and then you have differentiated the second term. Here whatever you have differentiated, now you have kept it as it is, and then you have differentiated the other term. Now you have also come across your quotient rule, which says if your function is given in u by v form, then you can write it as v square, v as it is differentiation of numerator minus your numerator as it is and differentiation of your denominator. Now children, moving on, now we'll discuss about chain rule. Chain rule is applied when the given function is not given in standard form. By standard form, I mean to say the way you have learned the formulae. Like you have learned that differentiation of sin x is cos x. So here your function sin x is in standard form because this angle is just only x. But what if it is sin x square? But what if it is sin cos and then x square? So these functions are not given in the standard form. That means the way which you have learned in the formula. So first of all, these types of functions are known as composite functions. That means they are framed by joining one or more than one function. So if it is sin x square or sin cos x square, then to find out the differentiation or derivative of composite functions, we need to apply chain rule. Let us understand chain rule by taking an example. Let's say I take the question as y equal to sin cos, say it is cos x square. Now this function is not given in standard form. So first of all, I try to change into standard form because I know only my formula in standard form only. So let's see how I can do this question as, here it is given y equal to this and you need to find out dy by dx. Now this is like you are given one box, then you are given another box, and then it is a bigger box. So we will convert this given box, smaller box, into some another term. That means we'll take it as let cos x square equal to u. That means I have taken this complete cos square as u. That means now my question has become y equal to sine u. Now you see, this is my standard form which is given just in u. That means I can calculate dy by du. That means I am differentiating my y with respect to u. Since the function is given in u, that's why I am differentiating in u with respect to u. So sine u is, you know, it is cos u. But I need to calculate dy by dx. This is not dy by dx. So what we have, suppose, let's see that side. Here it is again x square. This is not again in standard form. So again we'll say let x square equal to some other variable. That means say this is t. So now this has been converted into cos x square is t. So cos t equal to u. That means I will differentiate this u with respect to t now. So differentiating u with respect to t will give me cos t is minus sine t. But I need to calculate dy by dx. This is also not dy by dx. So let's move on here and see what I can do over here. Here again I can differentiate t with respect to x. So x square differentiation is 2 into x. How? I know that differentiation of x raised to power n equal to n into x raised to power n minus 1. So applying this direct formula, I get the differentiation of x square as 2x. But again I am not getting it as dy by dx. So let's see how I can get my dy by dx, which is asked in the question. So that means I need my dy up and dx down. So here I am getting dy by du. So let us write it like this, dy by du. Now I will form a chain so that these denominators will get cancelled with numerator, and then I can frame this dy by dx. So this is how I apply chain rule. This is dy by du into, take this as du by dt. So here du gone. I have got dy by dt, but I need dy by dx over here. That means whatever I have taken here, that also I have to take in chain. That means I am forming a chain to get the value of dy by dx. So here I am writing at dt by dx. Now put all the required values from above. This is dy by du, which gives me cos u, into du by dt, which gives me minus sin t, into dt by dx, which gives me 2x. Now you see, du gone, dt gone, so I am just left with dy by dx. So this is equal to minus 2x into cos u into sin t. But initially my question was given in x, so I need to convert this question in terms of x only. So you replace the value of u and t with cos x square and x square. So this is minus 2x cos of u is what? Cos x square. So this is cos x square and into sin t, and sin t is my x square. So this is your required answer. That means dy by dx of the given function. Have a look.